So here we are. I kind of hurried through that very last part, so talk a tiny bit more about number two, tectonic activity. The basic concept there is that where the continents are in relation to each other, and also geochemical processes like weathering of rocks near the surface that can take carbon dioxide in, uh, that sort of thing. These can affect total snow cover and atmospheric chemistry. But because tectonic processes, for example, continents only move a few inches a year, um, there just isn't the kind of change happening fast enough to explain what we've seen in the more recent decades and even century for that matter. Another one is volcanic eruptions. They put dust, droplets, and ash in the atmosphere, and they can have a cooling effect. So if we were to have over a long periods of time, lots of eruptions, and then the eruption rate dropped, we could expect maybe to see some warming because of that. But in fact, in this setting, we haven't seen any significant trend there. Um, Also, by the way, volcanic eruptions emit carbon dioxide, but that's something that was already addressed in Richard Alley's video. You might remember talking about the accounting of carbon dioxide. So there's no trends in this that suggest reductions that would cause a warming here in recent centuries. Solar output has shown little or no upward trend since 1978 when satellites began measurement, only periodic variation of less than 1% in 11-year cycles. Earlier records of sunspot activity related to solar output suggest an increase in solar radiation dating back 2 centuries, but not recently. I'm going to take a real quick look at climate.gov here at our original slide because I want to take you to that solar um, data that we have um, just to show you that. So we'll come down, have a look at that. Um, sun's energy, there it is. And I got to make this a little wider so you can see this better. Oh, it's up there. Yeah, there it is. Okay, here I am clicking and clicking, and it was already there. Let me pull this over so we can see this stuff better. Um, all right, I'm sorry, I'm a little slow here. Uh, let's go over where the center is best and see this is the sun's energy, and basically over time you can see the numbers in a given year. Is there a trend there? Nothing of note. So that's just a quick look at that. Let's go back now in our notes then to um, okay, now we're on Earth system variability. We'll take that from current slide. Sorry about this. I'm a little bit off cue here tonight, aren't I? All right, so there we go. Now, Earth system internal variability, such as the episodic El Nino Southern Oscillation, which we've seen some of, can have large effects on temperatures in any particular year or year and a half. By the way, that's about the time frame that those last. However, between 1000 and 1800, the overall proxy record is just looking at other indicators that tell us whether El Ninos were happening or not, shows nothing similar to the rate of warming seen since the last or the late 19th century. Um, so this is just, yeah, I mean, if we had more El Ninos recently, and that alone could have some effect, but we don't see that kind of a trend in that would cause a sustained temperature increase. So there's no compelling evidence, number six, that forcing mechanisms 1 through 4 or internal availability just above or a combination thereof can account for the rate of warming in the past century. Okay, so these are the leading natural causes. And I always tell students, hey, you want to make a career for yourself? Find a natural cause that's causing what's happening and make a compelling case for it. Get the physics right, get the data right for its change, and you will make your name for a name for yourself in science. There are literally tens of thousands of scientists who are trying to do exactly that, and nobody's been able to crack it. They're It's just not there. What's going on is human activities, as this slide suggests. Human activities have increased the concentrations of CO2 by about 30% or a little more now, and other greenhouse gases over the past few centuries. Basic physics provide support for the warming role of greenhouse gases, as do climate models that are based on physics and empirical observations, basically just meaning measuring temperatures, right? So basic physics, the stuff we looked at earlier, where um, in the 1800s, some of the early physicists actually did experiments with carbon dioxide and saw how it did absorb heat. What we think of as ground radiation. Um, that's the basic physics that later became worked out by the Air Force in the 50s as well, and a number of other institutions and scientific bodies. And the climate models, which basically take the physics and link them all together, um, all of these give us they point to greenhouse gases as being the biggest driver of this. The Intergovernmental Panel on Climate Change concluded that most of the observed warming over the years 1950 to 2012 is likely to have been due to the increasing greenhouse gas concentrations. Now, they did meet more recently, by the way, but they were looking particularly at how much reductions in emissions we would have to hold the temperature to 1.5 degrees C warming. And so they didn't come up with a statement quite of that nature, but the scientific certainty has increased. There's always the possibility in science of kind of overthrowing the existing thinking on something, but this body has been. But basically, they have this huge group of scientists who survey the literature in their fields and come up with a summary statement that everybody can sign on to. And the trends definitely are for increasing confidence rather than decreasing confidence. And it's not hard to understand why that is when you look at the science more carefully. Remember the process here. Just a quick review. The process in which greenhouse gases help warm the atmosphere. Here's how it works, right? Some of the shortwave radiation from the sun penetrates the atmosphere and is absorbed by the Earth's surface, which warms up. As it warms up, the Earth emits long-wave radiation, some of which is absorbed by the greenhouse gases in the lower atmosphere or the troposphere. Thus, solar radiation warms the Earth's surface, and then Earth radiation warms the troposphere. That's the order. Now remember also there is some warming because of the turbulent transfer of heat from the heated Earth itself to the air right above it. But if you're talking about the troposphere overall, say 18,000 feet, the major effect there is just that the greenhouse gases are concentrated near the surface and they're absorbing that Earth long wave radiation or infrared radiation. And that's the basic process. Okay, so what future changes in global climate are expected? So this is one of those where it gets kind of fun because future temperatures are likely to be driven mostly by future concentrations of greenhouse gases, which will be dependent on future emissions, which will be driven by all kinds of things. I've just listed some of the major ones. Not necessarily in order, by the way, and in fact, not in order. And I intentionally didn't want to put them in a particular order. But population matters some. Obviously, more people consuming at some level and using fuels to power their lifestyle and the systems that support them. As long as those fuels still have carbon dioxide emissions, then yes, population increase can be a factor. And even if the fuels themselves weren't, other things that we do as well as humans can influence it. So population matters. It's not nearly as important, though, as the consumption rates per person, but both matter, to be sure. A few centuries ago, there was only 1 billion of us, and now there's 7.7 billion of us. And yes, that has a big influence. And we also now, in countries like the United States, consume 100 times more energy than we did, say, 1,000 years ago per person. So it's both population increase and what we use in the way of resources and the way those resources affect carbon dioxide and other greenhouse gas emissions. Okay, so world economic growth. The challenge in this, of course, is we want to have prosperity for all. And just because we have economic growth doesn't mean we have that. But there's been a kind of assumption in economics that if you want to have economic growth reach everyone, uh, you have to have a significant amount of it. And so that's a whole nother subject I'm not going to really delve into in great detail here. But I would like to talk about technological trends. And by the way, world economic growth is largely driven by technological trends. And the technological trends, though, particular that we're talking about here, are trends in how we power our economies, how we power our industries. And so, can you think of some of these that could give us a lower carbon dioxide emissions, lower methane, which is the second most important greenhouse gas that we produce large amounts of in our activities? You think of something? Okay, well, one big trend is moving away from coal to make electricity and using more solar and wind. That's huge, huge. Coal has, in terms of the energy produced, the greatest carbon dioxide emissions of any of the three fossil fuels. You know what the three fossil fuels are? Can jot these down. I'm going to assume you know these from now on. The three fossil fuels, if you don't know this: oil, coal, and natural gas. Okay, so moving the largest amount of electricity made is made with coal in most countries. And when you shift away from coal to the well, hydro is one that we've had for a long time, but also more recently, solar and wind, you see some pretty amazing things happen. What other kinds of technological trends could play a role? How about electric cars? Okay, so these are some of the things we'll talk about a little later. Excuse me, in the term. Policies. Okay, policies are really important. Very recently, the Trump administration decided to call off the increased requirements for automobile makers to make fuel efficient vehicles. So that means that the miles per gallon of vehicles will not be improving as much or at all in the future. Why does that matter in this? Because the more fuel you use to drive a given distance, the more carbon dioxide emissions you have. So that's a bad policy if you want to go for a lower greenhouse gas future. That's so important. Could say a lot about that. We'll get into the policy stuff a little later in the term, not in this unit, but I just wanted to introduce some of these here. Historical events, major wars, political transition, and yes, I've been saying this for 20 years, and I have more bored-looking faces when I say epidemic diseases. I realize we're in a pandemic now, but the point is, yeah, these can be big things. And right now we're seeing a huge reduction in carbon emissions. But that's not the kind of cause that we want to see. That's very different from what we're wanting to see in the way of just shifting to a cleaner, more efficient energy future. This is just because we're shutting our economy down, and that's a disaster. So yes, the skies are clearer. There's been some amazing images of this sort of thing, but this isn't what we had in mind. Major wars can play a role. Political transition, very big, right? So you get some governments that don't care about climate change, or they're just in the pockets of the fossil fuel industry, like most English-speaking countries are today in the developed world, by the way. Canada, the UK, to a lesser degree, the United States, definitely Australia is in that boat. And so those transitions do matter in this context. All right, so those are a few fun things, and we'll get back to some of that later on. Just want to introduce it here. Global warming is likely to continue as greenhouse gas concentrations rise. Yeah, I mean, the more you're intercepting that radiation from the Earth, the more it warms. The higher northern latitudes are expected to continue to show the greatest temperature changes. Why? Because when it warms up, you melt ice, and when you melt ice, you absorb more solar radiation rather than reflecting it, and absorbing more of it makes it warmer. And so then when it's warmer, you melt more ice. So it's just one of these positive feedback loops. That's the reality. And finally, what about hurricanes and other storms? We'll get to that later on.